Welcome to this lesson on Coulomb's law. Today, we're going to explore one of the fundamental principles of electricity, the force between charges. This law helps us understand how charged particles interact with each other, which is essential for understanding everything from atoms to electrical circuits. Coulomb's law describes a fundamental relationship in nature. It states that the electric force between two charged particles is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. In simpler terms, this law tells us exactly how strongly two charged objects will push or pull on each other. The larger the charges, the stronger the force. The farther apart they are, the weaker the force becomes. Here's the mathematical equation for Coulomb's law. F equals K times q₁ times q₂ divided by r squared. This elegant formula captures everything we need to calculate the electric force between two charges. Let's break down what each part means in the next slides. Let's understand each variable in the equation. F represents the electric force, measured in newtons. q₁ and q₂ represent the two charges, measured in coulombs. The letter r stands for the distance between the centers of the two charges, measured in meters. And K is Coulomb's constant, which has a value of 8.99 times 10 to the power of 9 Newton meter squared per Coulomb squared. This constant helps us calculate the exact force in standard units. One of the most important aspects of Coulomb's law is the inverse square relationship with distance. Notice that r is squared in the denominator. This means the force is proportional to 1 over r squared. What does this mean practically? If you double the distance between two charges, the force doesn't just cut in half, it becomes 1/4 as strong. If you triple the distance, the force becomes 1/9 as strong. This inverse square relationship is crucial for understanding how electric forces behave. The direction of the electric force depends on the signs of the charges. When two charges have opposite signs, one positive and one negative, they attract each other. The force pulls them together. However, when two charges have the same sign, either both positive or both negative, they repel each other. The force pushes them apart. Remember this simple rule: opposites attract, and like charges repel. Let's work through an example to see how Coulomb's law is applied. Calculate the force between two charges of positive 2 microcoulombs and negative 3 microcoulombs separated by 0.5 meters. First, we identify our given values. q₁ equals 2 times 10 to the negative 6 coulombs. q₂ equals negative 3 times 10 to the negative 6 coulombs. The distance r equals 0.5 meters. And Coulomb's constant K equals 8.99 times 10 to the power of 9 Newton meter squared per Coulomb squared. With these values, we can substitute them into our equation and calculate the force. Let's summarize the key points about Coulomb's law. First, the force is proportional to the product of the charges. Larger charges mean stronger forces. Second, the force decreases with the square of the distance. This inverse square relationship means force drops off rapidly as charges move apart. Third, opposite charges attract while like charges repel. This determines the direction of the force. And finally, for calculations, always use Coulomb's constant, which equals 8.99 times 10 to the power of 9 Newton meter squared per Coulomb squared. Understanding these principles gives you the foundation for exploring electric forces and fields.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.